Hi everyone, welcome you all to the Brilliant Group of Institution. Today we are here to discuss the most important previous year question from the chapter Surface Chemistry for your upcoming term 2 examination. Let's go to question number 1. Out of AlCl3 and NaCl, so the species are given AlCl3 and NaCl, alright? Which is more effective in causing coagulation? What is the meaning of coagulation? Dear student, coagulation, it's also known as what? Precipitation or flocculation. What is meant by coagulation? If you have a positively charged colloid, if you want to convert them into the precipitate, if you have a positively charged colloid, if you want to make them as a precipitate, you have to add a negatively charged electrolyte. So a positively charged colloid, if you treat it with a negatively charged electrolyte, it will undergo coagulation or precipitation. The rule they said, Hardy-Schulze rule, right? Hardy-Schulze rule. There is an important question expecting from this area, Hardy-Schulze rule. What is Hardy-Schulze rule says that? If you have a positively charged colloid, we should add a negatively charged electrolyte to coagulate them. And opposite. If you have a negatively charged colloid, if you want to precipitate them, you have to add a positively charged electrolyte. Alright. So, they already given, here you are going to coagulate a negative sol, a negatively charged colloid. If you want to precipitate a negatively charged colloid or sol, we have to add a positively charged electrolyte or the species, right? Here you know AlCl3 having Al3 plus ion and 3Cl minus ion. And NaCl having Na plus and Cl minus ion. Dear student, your colloid is a negative colloid, so we need a positive species to coagulate. So the positive species is Al3 plus and Na plus. You don't need to bother about the negative charges. Now, whether Al3 plus or Cl minus, which is the best electrolyte or the species to coagulate your negatively charged colloid? Dear all, according to Hardy-Schulze rule, they says that if the charge on the species is greater, see the charge on the species, here it is 3 plus, here it is plus 1. If the charge on the species is greater, it's having high coagulating power. If the charge on the species is greater, it's having high coagulating power. So which will make more coagulation? AlCl3, because the aluminium is in greater charge. Alright, next one. What is the type of charge on AgI colloidal sol formed when AgNO3 solution added into potassium iodide? Dear student, there is 2 examples given in NCERT, very important. See here I am adding AgNO3, alright, silver nitrate, let me add into potassium iodide. You know silver is there, NO3 minus, K plus, I minus. The precipitate here forming is AgI. So AgI is the precipitate forming along with which one? KNO3, potassium nitrate. So AgI is the precipitate form. AgI is the precipitate form. It is preferentially adsorbed by. When AgI form as a precipitate, it is adsorbed by which ion? This I minus ion. Dear all of you, very carefully, when you add silver nitrate to potassium iodide, you will get silver iodide as a precipitate, but on which charge is adsorbing? I minus is adsorbing. Alright, the same question, I'm taking the opposite addition, like potassium iodide, let me add into silver nitrate, what will happen? Products are same. Which one? Silver iodide along with the potassium nitrate, same thing. But here also AgI is the precipitate form, but it is adsorbed by not iodine, it is adsorbed by silver, Ag plus. Carefully, all of you, listen. When silver nitrate added into potassium iodide, silver iodide will form and it is adsorbed by I minus ion. So which ion is adsorbing? I minus ion. And what is the charge of that I minus? That's already negative charge, right? So the overall charge of, now it is a colloid. Now the overall charge of the colloid is negatively charged colloid. Now it is a negatively charged colloid. And this negatively charged colloid, when it forms, it is absorbed by its counter ion. You may study its counter ion. So this layer is called the charged layer or fixed layer. It is surrounded by the counter ion, that is called the this is called the charged layer. The other one is called this charged layer or fixed layer. Okay, one more name. This colloidal, this ion charges, this negatively charged part is called fixed layer or charged layer. And the counter ion which is attacked, it will make a layer that is called the diffused layer or the mobile layer. And the difference between the energy, of the charged layer and the diffused layer, you may study that it is called zeta potential. Zeta potential, or it's also known as electrokinetic potential. Electrokinetic potential. Remember all of you this name, expecting question. What is mean by zeta potential or electrokinetic potential? It is a potential difference between the charged layer and the counter ion. There will be a counter ion here, they will make another layer. The potential difference between these two layers are known as what? Zeta potential. Which all layer? This is called fixed layer or the charged layer. The counter ion layer is called, it will make a counter ion layer, that is called diffused layer or mobile layer. The potential difference between this charged layer and the diffused layer is known as zeta potential or electrokinetic potential. Just a theory, I just mentioned here because it's important. Okay. So when we added silver nitrate to potassium iodide, we got silver iodide and it is absorbed by I- ion. So the overall charge of the colloid is negative charge. Which ion is absorbing? Okay, here iodine is absorbing, so that will be the charge of the overall colloid. What about here? When potassium iodide you added into silver nitrate, silver iodide form, where the absorbed one is silver ion. Now what is the charge of silver? Positive, so it will form a positively charged, okay, positively charged colloid. Okay, positively charged colloid can be formed. Clear? So which ion is absorbing, that will be the charge of the system. Okay. And next one. So the question, what is the type of charge on AgI, colloidal sol, formed when AgNO3 added into potassium iodide? Dear student, what's the charge? Negatively charged colloid is forming because the absorbing ion is I-. Alright, next one. Write the dispersed, it's a 1 mark question, expecting one. Write the dispersed phase and dispersion medium of paint. Dear all of you, we studied the classification of colloids. Colloids you can classify in 3 ways. First one depends on the nature of the dispersed phase and dispersion medium. See here the nature of the dispersed phase and dispersion medium: solid in solid, solid in liquid, solid in gas, liquid in solid, liquid in liquid, liquid in gas. Like that, different type of systems are there. It's very important to know this table. They will ask you MCQ question. Okay, very careful. So solid in solid is called solid sol, solid in liquid is called sol, solid in gas is called aerosol, right? Like that, we should know the name of the colloid and even examples also important. See the question, what is the dispersed phase and dispersion medium of paint? What is paint, dear student? Paint belongs to solid in liquid. So solid is the dispersed phase, liquid is the dispersion medium. Okay, solid in liquid. And they will ask you the other questions like what is about milk? Milk is an emulsion, liquid in liquid. And some other smoke, cheese, butter, like that. So we should know the example and the type of colloid, what is the nature of dispersed phase and dispersion medium. This table is important to know to answer MCQ question and this kind of 1 mark question. Next one. Same question regarding Hardy-Schulze rule. Out of barium chloride, so dear student, we have barium chloride and potassium chloride KCl. Out of barium chloride and potassium chloride, which one is more effective in causing coagulation of a negatively charged colloid? Dear student, your colloid is a negatively charged colloid. If you want to precipitate them or coagulate them, we have to use a positively charged species. You know, barium chloride having Ba2 plus and chlorine, right? And potassium chloride having K plus and Cl minus. Here you no need to bother about the negatively charged species because your colloid is a negatively charged colloid. If you want to precipitate them, we need a positive charged species. Which is the positive? Barium 2 plus and K plus. Which one having greater charge here all? Barium 2 plus. So it's having high coagulating power. Higher the, according to Hardy-Schulz rule, higher the charge of the ion, greater will be the coagulating power. So barium 2 plus means barium chloride is the best reagent to make more coagulation. Reason? According to Hardy-Schulz rule, you can explain. Next. A delta is formed at the meeting point of sea water and river water. Why? Dear student, you consider this is the sea water region. Okay, sea water. You know, sea water contain many electrolytes, especially NaCl. And the other side we have, you can consider the river water. Okay, this side, let us consider the river water. Just consider as a muddy water. Okay, muddy water. River water, the muddy river water is the colloid. This is actually your colloid. The muddy river water is the colloid. Whereas sea water is the electrolyte, which contain many electrolytes, right? Electrolytes, especially NaCl like that. You know what will happen here? When a colloid react, which is your colloid here all of you? The muddy river water is the colloid and your sea water is the electrolyte. When they join together, when their meeting point, you can see that colloid, when they connected to an electrolyte, it will undergo mutual coagulation. Yes or no? When a colloid come to, if your colloid is a charged one, when it come to the opposite charges, what happen? It will coagulate. So we can say that there will be a mutual coagulation can happen. Because of the coagulation, what forming there? Delta get formed. Okay, so that's a application of a coagulation one. So delta is formed at the meeting point of sea water and river water. You can explain through the which is colloid, which is electrolyte, what is the delta form means precipitate forming, everything you can explain. Next one. The most expecting question from this area, you have studied there are two types of adsorption in this chapter. Physical adsorption, it's also called physisorption. Chemical adsorption is also called chemisorption. It's very important to know the difference between physisorption and chemisorption, most expecting area. Physisorption is reversible while chemisorption is irreversible. You have studied a lot of data related to physisorption. Dear student, what is a physisorption and chemisorption? Physisorption means the adsorbate and adsorbent are connected through very weak van der Waals force of attraction. Right, a very weak force. What about chemisorption? In chemisorption, the adsorbent and adsorbate are connected through very strong chemical bond like ionic covalent bond, very stronger bond, correct. And in physisorption, you know, they will form multi-molecular layers, and chemisorption, they will form unimolecular layer or monomolecular, one layer. And you know, physisorption is not specific and chemisorption is specific, right? Specific in the sense, any adsorbate molecule cannot adsorb on a particular adsorbent. You know, chemisorption means actually there is a chemical reaction, chemical bonding they're forming. So certain substances, certain adsorbate only can adsorb on the surface of an adsorbent. It's specific in nature, but physisorption is a weak bond, not specific. Now, which is reversible, which is irreversible? Dear student, the physisorption is reversible because the bond is very weak. They are not making a new compound, right? Whereas chemisorption, the adsorbent and adsorbate are making very stronger bond. They are making a new product. When a product form, the desorption is very difficult, right? So physisorption is reversible and chemisorption is irreversible. Then you have studied physisorption, they are making a very weak bond, so their heat of adsorption, enthalpy of adsorption is very range, right? Very lesser one, 20 to 40, like a small range is there, 20 to 40 kilojoule per mole. Because they are making a very weak van der Waals force. When you know bond formation is an exothermic reaction, correct? So when adsorbate and adsorbent making a very weak bond, they will release a lesser amount of energy, around 20 to 40 kilojoule per mole in physisorption. What about in chemisorption? In chemisorption, they are making very stronger bond, around 80 to 240 kilojoule per mole is releasing because they are making a very stronger bond. Okay, so heat of adsorption lesser in physisorption, heat of adsorption is more in chemisorption. Then some other data. You may study physisorption, activation energy not required, but chemisorption, activation energy required. And the next one, physisorption normally favor lower temperature because, dear student, the adsorbate and adsorbent are connected through very weak bond. If you increase the temperature, what happens? This bond will break, desorption will happen. So physisorption favor low temperature. But what about chemisorption? Chemisorption favor little higher temperature, but we can't say very high temperature. Let us discuss detail. Okay. So generally we can say physisorption favor low temperature, chemisorption favor high temperature. Alright, I'll show you the table. Study all of you carefully. So physisorption is reversible while chemisorption is irreversible. I told you that in physisorption, the adsorbent, okay, adsorbent and adsorbate are connected through very weak bond, right? This bond is a very weak van der Waals force of attraction. Whereas in chemisorption, the adsorbent and adsorbate are connected through very strong chemical bonding like a ionic or covalent bond. So what happened? If it is weaker bond, see they are just making just holding, this adsorbate are just holding on the adsorbent. They're not making a new product, a new stable product. So when you if you want to replace the adsorbate from adsorbent, it's so easy, which means desorption. Desorption is so easy, so it is reversible because the bond is weak. But during chemisorption, the adsorbent and adsorbate are connected through very stronger bond. So once it is formed, it's a new product. So the detachment, like, or the desorption is not an easy process. So this is irreversible, whereas your physisorption is reversible. Physisorption is reversible. You can desorption and adsorption can be happen at any time, but chemisorption is irreversible. Once it is formed, it's a stable product. Okay, next one. So the final answer, all of you, physisorption. This is about physisorption, right? Physisorption is, we can say, reversible, whereas chemisorption is irreversible. Okay, irreversible. Next one. Give reason of the following observation. Question number 1. Physisorption decreases with the increase in temperature. We already said in physisorption, the adsorbate and adsorbent are connected through very weak van der Waals force. What happened when you increase the temperature? When you increase the temperature, this bond will break because this weak bond. So, and desorption will happen. Correct. So physisorption decreases with the increase in temperature, that is due to the weak van der Waals force of attraction between adsorbate and adsorbent. Second question. Addition of alum purifies the water. You may study it as an application of which one? The coagulation part. Dear all of you, alum. What is chemically alum? That's a question for your examination. What is chemically alum? Alum is a salt of which one? Sodium Na2SO4, sodium sulfate, along with aluminium sulfate, Al2SO4 thrice. It's a double salt, like sodium sulfate and aluminium sulfate mixture along with 24H2O, a hydrated form. This is called alum. Chemically, alum is a salt of sodium sulfate, aluminium sulfate with a 24 water molecule. You know this alum, what is the purpose of this alum? Dear student, if you add this alum into a not a pure water, a impure water, you know, impure water contains so many suspended particles, right? Suspended particles will be there. These suspended particles in this water, the impure water, can be settled down. These all particles can be settled down, means coagulation can be done or precipitation can be done by the addition of alum. So alum is a chemical which is used to precipitate or coagulate the suspended particles in a impure water solution. Brownian movement provides stability to the colloidal solution. You have studied what is Brownian movement. It is one of the application of which one colloidal is a property of a colloidal solution. What is actually Brownian movement? Brownian movement is the zigzag, right? It's a zigzag movement of colloidal particles. Why this Brownian movement is happening? Because the colloidal particles keep on bombarding each other. Because of the constant bombardment of this colloidal particle, they are in a random motion, and you know that Brownian movement we can observe only through the help of a microscope. So they can ask you which property of a colloidal solution can be observed only through a microscope. That is Brownian movement. Alright. So this is a zigzag random movement of colloidal colloidal particle. Why? Because of the keep on bombardment of colloidal particles between them. Okay, the question, why Brownian movement provides stability to the colloidal solution? How it is affecting stability? Dear all, if these colloidal particles are continuous random zigzag motion, it won't undergo coagulation faster. If the particles are just suspended and stationary, we can settle down so faster. Here settling of these colloidal particles is very difficult because they are in random motion. Okay, so that is the application. Next, give reason for the following observation. Question number 1, leather gets hardened after tanning. Tanning is a process to get hardness for the leather. Dear all of you, you know leather, how the leather is making from animal hides, right? So when this animal hide, you know, animal hide is a positively charged colloid, okay? It's a positive charged colloid. It's a positively charged one. When you add tanning, the tanning is a tan when you add to this animal hide. The tanning is a process where animal hide is a positively charged colloid. When it is treated, when it is undergo tanning process, you know, tanning the chemical which contain negatively charged species. Negatively charged species having with the tanning. So during the tanning process, negatively charged species are combining with our positively charged leather, means animal hide. What happened? Coagulation happen, means it will get stronger. Okay, so use the term coagulation or connect with the coagulation when you explain this answer. Lyophilic sole is more stable than lyophobic sole. You have studied colloidal particles based on their interaction between dispersed phase and dispersion medium. We can classify into two, lyophilic and lyophobic. What is meant by lyophilic? Lyophilic means they are solvent loving species. Lyophobic means solvent hating species, right? So lyophilic colloids, when the particle you added into a solvent, immediately they will make a bond and they will form colloid. Whereas lyophobic, they are water hating or solvent hating one. So we need a special technique to prepare lyophobic colloids. You may study that. Why lyophilic colloids are highly stable? The main reason is due to their high solvation. Lyophilic sole, dear student, they are solvent loving species. They have an immediate ability to make a bond with the solvent and immediately they will form colloid. So due to high solvation, lyophilic colloids are highly stable due to high solvation compared to lyophobic one. Okay, lyophobic one. So these are the question in the previous year, they repeated. So we will discuss again about lyophilic and lyophobic, some other types. Let's see. Write any three difference between physics option and chemistry option. Dear student, most expecting question from your examination for the term 2 examination from the area physics option and chemistry option. So all of you please study. We already discussed what are the differences between physics option and chemistry option. So all of you please be aware about that. Very important. Okay, what are the topic we discussed? Physics option, there is a weak van der Waals force of attraction between the dispersed phase and dispersion medium, right? And especially the here we are not dealing with a colloid system, so especially physics option, when you're saying the adsorbate and adsorbent are connected through very weak van der Waals force of attraction, whereas in chemistry option there is very strong chemical bonding. And physics option, activation energy not required for the process, whereas chemistry option, activation energy required. Physics option favor low temperature, chemistry option normally favor high temperature. During physics option, the bond is weak, so it will release less amount of heat, around 20 to 40 kilojoule per mole. Whereas chemistry option, they are making very stronger chemical bond, around 80 to 240 kilojoule per mole it will be releases, because bond formation is exothermic in reaction. All right, next one. And physics option is not a specific and chemistry option is specific, right? And some of them, physics option is reversible, whereas chemistry option is irreversible, right? So all of you study the property very carefully, it's important. Then give one example each of lyophobic sole and lyophilic sole. Dear student, for lyophilic, we already said lyophilic colloids means they have high attraction towards the solvent. Lyophilic means solvent loving. When you add the species into a solvent, immediately they can form colloid, right? Whereas lyophobic means water hating one, or solvent hating one, lyophobic. What are the properties we studied? Lyophilic colloids, solvent loving. Lyophobic is solvent hating. So lyophilic colloids, when you add the species into the solvent, immediately they will form colloid. No specific technique required. But lyophobic means they are solvent hating. If you want to prepare lyophobic colloids, special techniques are required. Lyophilic one is reversible. It means when you add the particle or the dispersive particle into the medium, they are forming immediately colloid, right? For example, you consider a substance you dissolved in water. It's suppose making a colloid. It's lyophilic. During evaporation, when you evaporate the system, what happens? Water will evaporate from the system. You will get the particles only, right? So the opposite, the opposite of colloidal formation happen. Initially, they form colloid. When you evaporate it, they separated. Correct. But the remaining particle to which if you add again water, it again can form colloid. So it is a reversible in nature. Whereas lyophobic is irreversible. Lyophilic is reversible. Lyophobic is irreversible. Because you can, by keep on adding the solvent, you can make it the colloid back. But lyophobic, I told you, special techniques are required. Okay. Give one example. Dear student, the example which may have studied in classes, lyophilic examples are, gum, gelatin, starch, cellulose, like that. If these kind of species, gum, gelatin, starch, something, if you add into water, immediately they will form colloid. Therefore, they are called lyophilic, solvent loving. Lyophobic examples are especially metals, silver, platinum, those kind of metals. They are not, if you immediately add into a solvent, it won't form colloid, right? Metals and their sulfides, metal sulfides, metal hydroxides, these all are belongs to negative, lyophobic colloids. Lyophilic colloids are gum, gelatin and starch. Lyophobic are metals, metal sulfides and metal hydroxides. Example. Why is adsorption always exothermic? Dear student, let me tell you something regarding adsorption. During adsorption, normally, okay, for all adsorption process, you know what is adsorption? There is an adsorbent, there is a surface is called adsorbent on which the particles are adsorbing, right? This is called adsorbate, right? Adsorbate. Here, during adsorption, actually what is happening? These adsorbate particles are making a bond with the adsorbent, bond formation. When a bond form, it is exothermic in nature. Okay, normally all bond formations are exothermic. So when adsorbate making a bond with adsorbent, heat will release. Therefore, enthalpy sign is equal to negative. You know, for an exothermic reaction, enthalpy change is negative in value. And what happens to entropy? You know, delta S. You know, entropy is a, the total degree of randomness of a system. More disorder the system, more randomness, entropy positive. Less, or if it is ordered arrangement, entropy very less. See, here adsorbate particles, initially they are in random, they are in disorder manner, right? After adsorption, their position is fixed and they can't move, right? They can't move. Their position is fixed and randomness decreases. Means entropy decreases. So entropy is negative. So during a general adsorption process, enthalpy is negative or entropy is, enthalpy is negative, yeah, and entropy also negative. Let me apply this entropy and enthalpy concept into the Gibbs energy. We know Gibbs-Helmholtz equation, delta G equal to delta H minus T into delta S. See, dear student, here delta H is negative. Okay, this is negative value minus temperature into delta S also, which one? Negative value, right? Negative value. It will be negative, negative, positive, but here there is a negative. Mostly enthalpy will be very high for during an adsorption process if it is a chemist option. So Gibbs energy also there is a chance to make it overall negative. So most of the adsorption process, delta H negative, delta S negative, even Gibbs energy also negative. You know, Gibbs energy negative mean reaction is spontaneous or feasible. It can happen. Okay, so this is the general concept during an adsorption. Just general adsorption process, enthalpy is negative. Why enthalpy negative? Because they are making a bond. Bond formation is exothermic in nature. They will release energy. All right, and entropy will be negative because the randomness is decreasing. They're getting ordered arrangement. And Gibbs, when you apply delta H and delta S into the Gibbs-Helmholtz equation, overall delta G also in common cases it is negative. Delta G negative mean reaction is spontaneous, means it can happen, feasible. Next, what are the dispersive phase and dispersion medium in milk? We discussed before. I told you this table is important for 1 mark question. Milk is an emulsion. All of you, milk is an emulsion. Emulsion is very simple to study, where in emulsion colloidal system, the liquid is dissolved in liquid. So dispersion medium and dispersed phase both are liquid. Okay, emulsion means liquid in liquid. Then, what is the effect of temperature on chemisorption? Dear all of you, when you observe the graphical representation which is given in textbook for the relation between chemisorption and temperature, we can observe like this. If you apply the temperature on x-axis and x by m on y-axis, what is x by m? The extent of adsorption. How much adsorption happened? X by m represent extent of adsorption. The graphical representation is showing like this. This is the graphical nature you're observing when temperature plotted against x by m means extent of adsorption for chemisorption process. What you understood by this one? When you increasing the temperature, the extent of adsorption also increases. Means chemisorption, I told you, normally favor high temperature. So at a high temperature, the extent of adsorption also taking place so fast, and after that, it's decreasing. After a particular temperature, it's decreasing. Why? Dear student, even it is a chemical bonding, it's a stronger bonding. When you keep on increasing the temperature, the bond will break, desorption will happen. Correct? So in chemisorption, initially when you increase the temperature, adsorption also increasing, but it meet at a maximum point. After the temperature, the desorption will happen and its extent of adsorption is decreasing. Alright, this is the nature for chemisorption. What type of forces are responsible for the occurrence of physisorption? Come on all of you. In a physisorption process, the adsorbate and adsorbent are connected through very weak van der Waals force of attraction. Correct. Name the temperature above which the formation of micelles takes place. Dear student, micelles we studied under the class of associated colloid, right? Micelles we studied under associated colloids. What are associated colloid? Associated colloids at a low concentration and high concentration, they exist as different species. At a low concentration, they exist as normal strong electrolytes. Normal strong electrolytes. Dear student, colloids belongs to associated colloid. Associated colloid at a low concentration, they exist as normal electrolyte, but at a high concentration, they exist as what? Micelles. They will form micelles, right? Micelle. So the question here, name the temperature above which the formation of micelle takes place. You have studied very important point here. Micelle formation happen only above a particular temperature. The temperature is called Kraft temperature. Yes or no? Kraft temperature. What is Kraft temperature? The temperature above which micelle formation can happen. One more topic you have studied after Kraft temperature, that is called CMC. What is CMC is called? Critical micelle concentration. CMC, critical micelle concentration. Same definition. What is Kraft temperature? The temperature above which micelle formation can happen. CMC is called, it's the concentration above which micelle formation can happen. That's it. So Kraft temperature and CMC is 1 mark question for exam. So careful all of you. So Kraft temperature is the temperature above which the micelle formation can happen. CMC, critical micelle concentration, mean it is a concentration, a minimum concentration above which the micelle formation can happen. Then, based on the type of dispersed phase, What type of colloid is micelles? Dear student, depends on the type of dispersed phase, especially the size of the dispersed phase. We classifying colloid into three types. One is called multimolecular colloid. The other one is called macromolecular colloid. The third one is called associated colloid. We just discussed now. Associated colloid. Depends on the type of the dispersed particle, we can classify the colloid into three sets. One is called multimolecular, macromolecular, associated colloid. Regarding associated colloid, just we discussed now. Multi and macro we can discuss in the next question. Here the question, based on the type of dispersed phase, what type of colloid is micelle? Micelle belongs to associated colloids when at a high concentration. We discussed just before, at a low concentration they act as what? Normal strong electrolyte. At high concentration only they can act as what? Micelles. Alright. Next. Define the term Tindal effect. I'm expecting the question, not this. Tindal effect, you know very well that you studied from 9th grade onwards. What is Tindal effect? You have a colloidal solution. You have a colloidal solution through which you are passing a monochromatic, a light that you are passing, okay, by using a torch or something, you are passing a light. When you are passing a light through a colloidal solution, the path of the light is visible, right? The path of the light is visible, right? Why? You know, the colloidal particles having a dimension 1 to 1000 nanometer. This colloidal part, the light hit on this colloidal particle and gets scattered. Because of the scattering of light, we can see the path of the light. So the Tindal effect means they want to ask you define Tindal effect something. So we should know that. What is Tindal effect? It is the process of scattering of light when a light passes through a colloidal solution, and because of the scattering of light, the path of the light is visible throughout the solution. That is called Tindal effect. Mostly expecting question is, what are the conditions to show Tindal effect? The colloidal particle, any colloidal particles cannot show Tindal effects. Two conditions are there. What are the two conditions for the colloidal solution in order to show Tindal effect? First condition, the diameter of the particle, dear student, the diameter of the colloidal particle should not be much smaller than the wavelength of light used. Please note it, all of you. In order to show Tindal effect, the colloidal particle, their diameter of the particle should not be much smaller than, it should not be too smaller than the wavelength of light used. Okay, it should be bigger, little bigger, then only the scattering of light will happen. Second condition, if you are taking the refractive indices of the dispersed phase and dispersion medium, their difference should be greater in magnitude. The refractive indices of dispersed phase and medium, their difference should be greater in magnitude. If these two conditions satisfy, those solutions can show Tindal effect. So carefully study what is Tindal effect and what are the two conditions. Next, in reference to Freundlich adsorption isotherm, you know what is mean by adsorption isotherm? Adsorption happening at a constant temperature, isotherm, constant temperature. One of the scientists, Freundlich, explain about that. Write the expression. What is the expression for Freundlich adsorption isotherm, dear all of you? You have studied that x by m is directly proportional to p to the power 1 by n. This is called the relation Freundlich adsorption isotherm. What is meant by x? X is the number of adsorbate particle, the amount of adsorbate particle, and m is the mass of adsorbent. So dear student, x represent the number of or the amount of adsorbate, how many adsorbate are absorbing. M represent the mass of adsorbent. So an overall term x by m represent the extent of adsorption. What is the adsorption? What is the level of adsorption happen? See, x is the number of adsorbate. So x by m greater mean more adsorption can happen. It's happened, right? X by m represent extent of adsorption. That's equal to p to the power of 1 by n, where n is a constant, p is the pressure. So we can make it as a proportionality constant. X by m is equal to k into p to the power 1 by n. Then we are making a graphical representation, right? Taking logarithm on both sides. So I can write log x by m is equal to log of k into p to the power 1 by n. So let me make some more simplification. Log x by m is equal to, this is in the format of log a into b. Log a into b is log a plus log b. So I can write it as log k plus log p to the power 1 by n. So log x by m is equal to log k plus, this is log a to the power b form. Log a to the power b is b into log a. So 1 by n into log p. This is in the format of a straight line. What is the straight line equation? Y is equal to mx plus c. Y is equal to mx plus c. So let's draw a graphical representation. Here you need to write only the equation, but they can ask you a question regarding graphical expression. Y axis, what you have? Log x by m. Log x by m is on y-axis. What do you have on x-axis, dear student? Log p. Log p on x-axis. And your slope is m. It is a positive slope. So the nature of the graph will be inclined line. And what is the slope of this line? If you take the slope of this line, you're getting, what is slope? M. M is equal to 1 by n. That's the slope. And what is the y-intercept? Y-intercept is c. That is log k. So they can ask you in frontal adsorption isotherm, what is the slope, what is the y-intercept, what is on y-axis, what is on x-axis, important. Next one, write an important characteristics of lyophilic. We studied lyophilic is a solvent-loving colloid. When you add the particles, or when you dissolve the particle, or when you add the particle into the medium, it immediately forms colloid, and it is reversible in nature, and they are highly stable colloid due to high solvation. And some examples also you can specify: gum, gelatin, starch, etc. Okay, already discussed. Of physisorption or chemisorption, which has higher enthalpy of adsorption, we studied in physisorption. Okay, during physisorption, you know, I told you they are making a bond, right? Adsorbate and adsorbent are making bond. They are making a very weak bond, so less amount of energy will release. Around 20 to 40 kilojoule per mole of heat only releasing, because they are making a very weak bond. But what about chemical? In chemisorption, they are making very stronger bond. Around 80 to 240 kilojoule per mole of energy will release, because the bond is very stronger bond. Okay. So why greater mean? Because of the strength of their bond, through the way you can explain it. What are lyophilic and lyophobic colloid? We already discussed, right? Hope you can able to answer. Which of these salts can be easily coagulated? That's very important question, dear student. We have lyophilic colloid and lyophobic colloid, right? Lyophilic and lyophobic. Which is more stable, dear all? Come on fast. Which is more stable? Lyophilic colloids are more stable, right? This is more stable due to high solvation, high ability to make a bond with the solvent, and immediately they will colloid. Whereas lyophobic is which one? Unstable. They are not stable one. So lyophilic are more stable, lyophobic are unstable. What's the reason? Lyophilic is more stable due to high solvation. Now, question, which of these colloid can be easily coagulated? The answer is lyophobic, because they are unstable. If they are unstable, if they come in contact with a oppositely charged electrolyte, immediately they will undergo coagulation, because an unstable compound ready to undergo something to get stability, right? So lyophobic colloids are unstable, so they are ready to undergo coagulation. Then what about lyophilic? It won't undergo coagulation faster, because it is little stable. You have studied the principle regarding this concept, that's called protective colloids. Protective colloid. What is a protective colloid, dear all of you? What is meant by protective colloid? Dear all, lyophobic. If you have a lyophobic colloid, if it is simply staying there, when a oppositely charged species come, immediately it will undergo coagulation or precipitation or flocculation. Why? Because this is unstable. Now I can protect it from coagulation by making a layer of lyophilic. I'm going to make a layer with a lyophilic colloid. Now this system can undergo coagulation faster? No, because lyophilic, a protective layer is there. He is the one which is stable, it won't undergo coagulation faster. So who is the protective colloid here? Lyophilic. Okay, so lyophobic is unstable, so immediately it can undergo coagulation. But it can stop or it can prevent by the addition of which one? A lyophilic layer. So lyophilic layer, here it is act as a protective colloid. Clear all of you? Okay, next one. What is the difference between multimolecular and macromolecular? I told you depends on the nature of the dispersed phase particle. Colloids are classified into three: multimolecular, macromolecular and associated colloid. Regarding associated colloid we discussed before. Now it is related to multimolecular and macromolecular. Multimolecular colloids mean their particles are very, here the classification based on the size of the particle. Okay, they're very less smaller or bigger like that. It means based on the nature of the particle. So based on the nature of the particle, what is the meaning of multimolecular? Multimolecular mean their particles are very smaller. So if they are very smaller, initially they are not in the colloidal range 1 to 1000 nanometer. They are very small, very less than 1 nanometer. So how they can get into colloid? By the aggregation. These particles aggregate together, mean join together and get into colloidal dimension around 1 to 1000 nanometer. These type of colloids particles are called multimolecular colloids. See all of you. They are formed by the aggregation of large number of atoms or molecule which generally have diameter less than 1 nanometer. So initially their size is less than 1 nanometer, so they will join together, aggregate together, they will get into colloidal dimension. What about macromolecular colloid? Their sizes is already bigger in size. So that macro, right? Macro, bigger in size. So multimolecular, macromolecular. And one more thing, we studied lyophilic colloids and lyophobic colloids, right? Multimolecular colloids are lyophobic colloids. Okay, lyophobic colloids. Keep in mind. What are the examples we studied for lyophobic, dear all? Metals, metal sulfide, metal hydroxide. That belongs to multimolecular colloids also, because multimolecular colloids are generally lyophobic colloid, whereas macromolecular colloids are lyophilic one. Lyophilic colloids means gum, gelatin, starch, etc. See, starch, etc. Okay. And this is the major topic you have to remember this. So multimolecular colloid, macromolecular colloid, their difference is important. And what about associated colloid? I told you multimolecular colloids are generally lyophobic and macromolecules are lyophilic. What about associated colloid? They contain both lyophilic and lyophobic part. You studied micelle formation. In micelle formation, the soap which contain a lyophilic and lyophobic part. Correct. So associated colloids having both lyophilic and lyophobic part. Okay. They are formed by the aggregation of large number of ions in concentrated solution. I told you associated colloids, if they want to act as a micelle, it only happen at a high concentration. We discussed associated colloid at a low concentration, they act as stronger electrolyte, normal electrolyte, whereas at a high concentration, they act as which one? Micelles. Okay, so study the difference, all of you, important. Next one, what happens when a freshly precipitated FeOH thrice? So your precipitate now is FeOH thrice, right? Ferric hydroxide. This is the precipitate. Is shaken with a water containing small quantity of FeCl3. So FeCl3. Dear student, FeOH thrice is a precipitate. Precipitate, we studied a precipitate when you treated with a electrolyte. It will form which one? Colloid. A precipitate when you treated with a species. The species we will generally called as term is there, I will tell you. So FeOH thrice is a precipitate. When FeOH thrice you added into or treated with the FeCl3, ferric chloride, it will form a colloid of FeOH thrice. It will form a colloid of FeOH thrice. It is adsorbed by this Fe3 plus ion. Fe3 plus ion, a positively charged colloid. So dear all, let me conclude. When FeOH thrice, it's actually a precipitate. You treated with the FeCl3. It will form a colloid of FeOH thrice. It is adsorbed by Fe3 plus ion from FeCl3. So overall the charge of the colloid is positively charged colloid. Now what is this process is called? It's called what? Peptidization. What is meant by peptidization? It is a preparation of a colloid from a precipitate by adding a peptidizing agent. Peptidizing agent. What is that? The process of converting a precipitate into colloid, by the addition of a peptizing agent is called what? Peptidization. It's a method of preparation of colloid. So here colloid is forming. Why is a finely divided substance more effective as an adsorbent? Dear all of you, if you consider a iron rod as an adsorbent, and I'm making them as into the powder. So powder in suppose it is in the powder form. Okay, many number of powders can be make it. A iron rod and a iron powder, which is the best adsorbent? Who can act as I'm same mass? Okay, same mass. The same rod I'm split it into like this as a fine powder. Where is the reaction happen so faster? You know that in the powder form, because when you make the solid or something into the powdered form, their surface area increases. Surface area, you know, it's a very big factor for adsorption. We see if surface area increases, more active sites are there to react. Okay, so the reason we can say why is a finely divided substance is more effective as an adsorbent, because when you make the substance into finely powdered form, the surface area increases. Surface area is proportional to the adsorption, rate of adsorption. As the surface area increases, more adsorption sites will be there. Reaction can be happen so fast. Next. What is special about the following term? Already discussed, dear student, Kraft temperature. Can you tell me what is Kraft temperature? The temperature above which micelle formation can happen is called Kraft temperature. I think in the before session we discussed one more topic regarding just below Kraft temperature, right? CMC, critical micelle concentration. Kraft temperature is the temperature above which micelle formation can happen, whereas what is CMC? CMC means the concentration above which, a minimum concentration above which micelle formation can happen. What is mean by sorption? Dear students, sorption. What is mean by sorption and desorption? Sorption mean the process in which both adsorption and absorption happen simultaneously. Right? A process in which both adsorption and absorption happen. Adsorption and absorption happens is called sorption. One of the example you may studied, dyeing of cotton fibers. Then what is mean by desorption? Desorption mean the process of removal of adsorbate particle from the surface of an adsorbent is called desorption, means removal of adsorbate. Write the differences between physisorption and chemisorption for the following term. Dear students, specificity. Come on all of you. Physisorption is specific or not specific? Physisorption is not specific. Any adsorbate particle can adsorb on the adsorbent because the bond is very weak. But chemisorption means it's a chemical reaction. The adsorbate and adsorbent are specific. Okay. So physisorption is not specific. Chemisorption is specific. Then temperature dependence. You know, physisorption favor low temperature, chemisorption normally favor high temperature. Reversibility, which is reversible. Physisorption is reversible. We can adsorption and desorption can be happen because the bond is weak bond. But chemisorption, once it is formed, it's a new product. The reversible reaction is not possible. So physisorption is reversible. Chemisorption is irreversible. Enthalpy change. We discuss the enthalpy change. During a physisorption, they are making a very weak bond. So less amount of energy releasing, around 20 to 40 kilojoule per mole. Whereas in chemisorption, very strong bond is forming. So more amount of energy release, around 80 to 240 kilojoule per mole can be removed. Okay. Then define peptidization. Just we discussed now. Peptidization means if you have a precipitate, suppose if you want to convert this precipitate into colloid, this process is called peptidization. Peptidization is a preparation of colloid from a precipitate. Simply the precipitate won't converted into the colloid, right? We need to add some agent that is called peptizing agent. So let me define what is peptidization. Peptidization is a process of conversion of a precipitate into colloid by adding a peptizing agent. It's called peptidization. Then explain what is observed when. Question number 1. Dear all of you, listen carefully. Question number 1. An electric current is passed through a sol. Sol is a colloid, right? Dear all of you, if you consider a colloidal system, you know, colloidal systems are charged one. Suppose it having positive and negative charged species. What will happen? An electric current is passed through a solid. Dear student, when you pass electricity, you know, normally we will place which one electrodes there, negative and positive terminal, we will cathode and anode we will provide, and we will pass electricity. When you pass electricity through the solution, the charged particle will go to the or will move to the opposite pole. Means this is the positively charged species, they will go to negative terminal, and the negatively charged species goes to the positive terminal. This process you may study that it's known as what? Electrophoresis. Right? Electrophoresis. What is meant by electrophoresis? It is the movement of particles, colloidal particles, to their opposite poles. Opposite poles when an electric field is applied is called electrophoresis. Very important term, all of you. Electrophoresis. Okay. So an electric current is passed through a solid. The colloidal particles can move to their opposite pole. That's called what? Electrophoresis can happen. Question number 2. A beam of light is passed through a solid. What happened here, student? Tindal effect, right? Tindal effect, and definition, their condition, everything, you can explain it. And an electrolyte, NaCl, is added into ferric hydroxide. Yes, student, a ferric hydroxide. FeOH thrice. Ferric hydroxide is a colloid, right? NaCl is a electrolyte. What happened? A colloid, when you treated with an electrolyte, what happened? It will undergo coagulation or precipitation or flocculation. Correct? So the first one is electrophoresis, second one is Tindal effect, the third one is coagulation. Explain the following term. Dialysis. What is meant by dialysis and electrodialysis and ultrafiltration? These all are the purification of colloids, right? Let me tell you a small idea about first one, dialysis. What is dialysis? We are taking a beaker. The beaker is with a membrane. There is a membrane. This membrane, you studied that it's called animal membrane. This membrane is known as animal membrane or parchment membrane or cellophane membrane. What are they? This is called dialyzer. This device is called dialyzer, and there is a membrane. This just like a sac. This membrane is called what? It's made up of animal membrane or a parchment membrane or cellophane membrane. What is the speciality of this membrane? Through this membrane, colloidal particles cannot move. So here I am taking the impure colloidal particle. Okay, through this membrane, this white colored one is the our colloid particle. And inside the same chamber, I am taking some. This is the water soluble one. These are water soluble impurities or the substances present in the particle. So dear student, dialysis, electrodialysis and ultrafiltration, every technique we are using to purify colloids. Prepared colloid we can purify. Dialysis is the first step. There is a parchment or cellophane or animal membrane in which colloid and water soluble particles are there. What is our purpose? We want to remove the water soluble particle from that, and we want to make our colloid little pure. Simple one. Here just applying water. A stream of water, running water we are applying. So through this running water, what will happen, dear student? The water soluble particles just come out from the membrane to the running water system, and you can, through the one opening, we can remove those particles. This is called simple process, a diffusion. The simple process is called dialysis. So dialysis is a purification technique of impure colloid, where water soluble particles can be removed from the colloid system, because colloid particles cannot move through the parchment membrane, but these water soluble particles can move. So when you pass water, a stream of water, the water and the water soluble particles come out from the membrane and they will dissolve and they can remove from the system. But it is a very slow process. Dialysis is a very slow process. We can make it faster through electrodialysis. How we can make it faster? The dialysis process, how we can make it faster in electrodialysis? Very simple. Just apply some electric field. If you apply electric field, means positive and negative terminal when you applied, electrodes or the electricity when you passed, what happened? Colloidal particles, you know, charged one, and the other particles, if it is a charged particle, if your impurity is also charged particle, what happened? The charged particles, they can go to the opposite pole. If your impurities are in a negatively charged something, what happened? There's negatively charged particle, they will go to the positive terminal. So the movement of this ion, the water soluble, those ion particle, charged species, to the stream of water, you can make it very fast by applying electricity. That is called electrodialysis. So dialysis is a slow process. To make it faster, we are using electrodialysis. What is ultrafiltration? That's an entirely different process. Ultrafiltration means we are taking a chamber and let me split the chamber by using a membrane, a filter paper. This is the filter paper. This is called ultrafilter. So ultrafilter paper, a same beaker, I'm just splitting into two by using an ultrafilter paper. They will ask you a one more question, dear all. What kind of material used for preparing this filter paper? Here I told you how this membrane is made. This membrane in dialysis is made up of animal membrane, parchment membrane or cellophane membrane. In an ultrafiltration process, the ultrafilter paper, how they made? It is made up of a solution that is called collodion solution. Collodion solution. This filter paper, ultrafilter paper is made up of, through the ultrafilter paper, colloidal particles can't move. Size is very small. So collodion, this ultrafilter paper is made up of collodion solution. What is collodion solution? Collodion solution is chemically 4% nitrocellulose. Collodion solution is a 4% nitrocellulose in a mixture of alcohol and ether. Dear all of you, collodion solution is a solution by using they made the ultrafilter paper. The ultrafilter paper through which colloidal particles cannot move, and this is made up of collodion solution. It is 4% nitrocellulose in a mixture of ether and alcohol. Now let's go to the process. Dear student, initially in the right chamber, let me put our colloids. Okay, these are our colloid particles. Consider this is our colloid particle. Into that, let me add the impurities. Okay, already there in the impurity because it is an impure colloidal solution. So this is our impurities. Okay, impurities. Their size is okay. These impurities can move through the the filter paper, but colloidal particles can't move. What happened? So gradually, when you place a solution of impure colloid here, these particles gradually try to move from right chamber to left chamber because through the membrane it can move. But it's initially it will be a slow process, but you can make it faster. How? We are not applying electricity. Here we are actually applying pressure on this side. If you apply pressure on this side, so when you apply pressure, what happened? The movement of the impurities will make it so faster. Okay, this process or removal of impurity from a impure colloid to make it as a pure colloid is known as what? Ultrafiltration techniques. So any one of them can be a question for exam. Next one. Explain the preparation of colloid. Dear student, total 3 methods are there for the preparation of colloid we are discussing in this chapter. First one is chemical method. In laboratory, how we can prepare colloids. Total 4 techniques are there in chemical method. Double decomposition, there is an oxidation, there is a reduction, and also the hydrolysis. So total 4 techniques we are using to make a colloid through chemical method. Double decomposition, oxidation, reduction, and hydrolysis. It's important to know the equation, especially through this each reaction which colloid they are preparing. All of you, through double decomposition they are preparing arsenic sulfide colloid. Through oxidation they are preparing sulfur colloid solution, and through reduction they are making gold solution, colloid. Through hydrolysis they are making FeOH thrice. Maybe one objective question also they can ask. So important to know the 4 reaction and through which each reaction which of the colloids are preparing. Second one is called Bredick's arc method, or it's also called electrical disintegration method. Bredick's arc method is an easy method. We are taking a chamber, inside one more chamber, And in the chamber, let me add our dispersion medium. Okay, here we have our dispersion medium. Dispersion medium is there. And especially all of you, Bredik's arc method is used for the preparation of mainly 3 colloids. They are platinum, gold and silver. Gold, platinum, silver, these kind of colloidal solution you can prepare through Bredik's arc method. The method is simple. Just take here, suppose you are going to prepare a platinum solution, platinum colloid solution. So you take 2 platinum electrodes. Okay, if you want gold, okay, take gold electrodes. And it is connected to the positive and negative terminal. Alright, so electricity is passing. So this is the experimental setup. One more thing is there, just below you can able to see some of the cubes are there. Which one? Ice cubes. Okay, so here we are placing a ice cube. Alright, this is the experimental setup of Bredik's arc method or electrical disintegration method. Here I told you mainly it is using for the preparation of platinum, gold and silver colloidal solution. Which electrode you want, that 2 electrodes we connected with electricity, and we are just keeping in a dispersion medium, and below there is an ice bath. Now let's go for the experiment. When you pass electricity through the solution or the electrodes, a electric arc is struck between the 2 electrodes. When electricity passed through the 2 electrodes, a electric arc is struck between the electrode. When the electric arc formed, the metal starts to evaporate. The metal, this is the metal rod, they starts to evaporate. When they starts to evaporate, the evaporated form, that is in the colloidal dimension. And what is the need of this ice bath, dear student? Now the metal rod is start to evaporate. So the evaporation, the water molecule which contain our colloidal particle, our metal, we want to deposit them in our dispersion medium. Right, so that we need ice bath through condensation. The produced vapor metals, metals are converted into vapor state. The vapor state we can cool down. That's by the process evaporation. Right, first evaporation happen, then condensation. So by what is the need of ice bath? To condense the the vapors. So the vapors which contain our metal in the colloidal dimension, and they will deposit by the process of what? Condensation by using ice bath. So those particles come to the dispersion medium and they will form colloids. This is called Bredik's arc method. Peptidization we already discussed, right, dear student? What is meant by peptidization? It is a preparation of colloid from precipitate. A colloid is prepared from a precipitate by adding a peptizing agent. Is called peptidization. Okay, so these are the major topic in the chapter surface chemistry. So in surface chemistry chapter, mainly you have to focus on what is the difference between adsorption, absorption, what is the difference between physisorption, chemisorption. During adsorption, what all things happen to enthalpy, entropy, Gibbs energy, and what are the example for each. Okay, and especially colloidal system, what are colloids, their dimension, what are the 3 different type of classification of colloid, and their preparation and their properties and their purification. Okay, all including all examples. And finally we are studying what is the some terms like what is coagulation or precipitation or flocculation. Regarding the rule, we studied Hardy-Schulze rule. In Hardy-Schulze rule we studied higher the charge on the species, higher coagulating power. One more thing, all of you, we discussed, if you have a negatively charged colloid, if your negatively charged sol or colloid, if you want to precipitate them, we are using a positively charged species, right? We studied Al3 plus, barium 2 plus and Na plus. If you consider these species, who can make more coagulation faster? Al3 plus. According to Hardy-Schulze rule, as the charge of the ion increases, its coagulation power increases, right? So its coagulation power is greater for Al3 plus. One more thing, there is a term is called coagulating power, is also called flocculation power. There is one term you have to remember. The coagulation power is inversely proportional to coagulation value. Very carefully remember. According to Hardy-Schulze rule, as the charge of the ion increases, its coagulation power increases. It can make more coagulation faster, precipitation faster. But if the charge on the ion is very greater, its coagulation power greater, but coagulation value lesser. Because coagulation power is inversely proportional to coagulation value. Finally, all of you, according to Hardy-Schulze rule, if the charge on the ion is greater, it's having high coagulation power and low coagulation value. Alright, so this Hardy-Schulze rule is also important one, and study all the example and lyophilic, lyophobic, multimolecular, macromolecular, associated colloid, micelle, what is Kraft temperature, critical micelle concentration, okay, and the Tindal effect, Brownian moment, what is a condition to show Tindal effect. So it's a pure theory chapter. Especially one more thing you have to remember, Freundlich adsorption isotherm related graphical question and their expression related questions will be there. So all of you confidently prepare the chapter surface chemistry for your upcoming term 2 examination. Hope you clear the concepts and question. So most of the questions are repeated, or these are the previous year questions. So we will meet again with some other chapter in the upcoming classes. So thank you all. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.